Hello, everyone, and thanks for having me over here. My name is METE BAKIR. I'm the Materials Engineering Manager here at Turkshare Space. And also, I'm an assistant professor here in Ankara at Ankara Yıldırım Beyazıt University in Mechanical Engineering. And I've been in Turkey since 3.5 years, working on this materials engineering projects here at Turkshare Space. So here's my contact address. You can reach me if you have any questions, and I can share the slides with you if you request, at the end of this presentation. So I wanted to first take some time to introduce our company. It's a well-known company in Turkey in production of aircraft platforms, helicopters, and the aircrafts. And I just want to give some brief introduction of what we do and how we do it. And then I'll just dive into the composite materials, and I'll explain some R&D projects we have. So Turkshare Space is a multinational company with joint ventures, including Turkish engine industry and TR Mechatronics, some satellite companies. We have some joint ventures in the United States, in Pakistan, Malaysia, in Europe. I'll explain the details in the following slides. So the company is growing rapidly since 2016 and 17, and we have more than 13,000 employees, including engineers, technicians, and specialists. And we have several air platforms that we are currently manufacturing or developing, and we do have some commercial side as well. And we have some domestic branches here in Ankara and other cities in Turkey, include our headquarters in Kahramanmaraş. Let me switch to this laser pointer. We have offices in several universities in Ankara, including METE, Hacettepe, and we have a really big office in Teknopark, Istanbul. We recently opened an office in Antalya, Teknokent, Istanbul Technical University, Yıldız Technical University, TÜBİTAK Bilgem, and Bursa. So we are expanding these offices to different universities as well. It'll be announced soon, probably in a couple of weeks. So it'll be multiplied by several factors. So it'll be as well as being a multinational company, will be a locally grown aerospace manufacturing company. Speaking of domestic branches, we also have some international branches, including the United States. Personally, I'm the coordinator of Turkshare Space USA offices. We have 4 offices in Urbana, Seattle, Wichita, and Atlanta. And we have offices in Europe, including Germany, France, England, United Kingdom, and Spain, and some offices in APEC countries, Pakistan, Kazakhstan, Malaysia, and Indonesia. So we are growing and expanding through these offices, and we have customers, we are getting customers through having these offices. These offices not only function for getting customers, also we currently actually do some R&D work with the universities or some small companies in those countries through having these offices. So we are also, as I said, a multinational company or a global company. Global means having global partners or collaborators. We currently work with Boeing, Bombardier, Airbus, and Sikorsky. We do projects with them, and we produce air platforms or sub-assemblies for them. So it's a big venture for us to get some income as well and get some experience through these companies as well. So getting to the composites, in Ankara, that's our headquarters. It's over 4 million meters square, and indoor space is more than 600,000 meters square. Here, I'm currently in that building as well. We have Turkshare Space Composite Manufacturing Facility, which is 95,000 square meter. It's the largest composite manufacturing facility in Turkey, 4th largest under one roof in the world. and it has the capacity to produce the composite parts for aerospace industry over 2% of like the total volume. So it's a big like facility. We have spent several $100 million to get this facility like built, and I'm currently like located there as well. We have clean rooms, autoclaves, some quality tools like the CMM, some metal cutting tools as well. So we have also a big like sub facility for surface treatment and coating processes. So as I said, I'm the materials engineering manager. I think like our department is the materials engineering department, and we are currently building a material process and calibration laboratory, which is over 17,000 square meter. And we are going to have 2,000 engineers for material process and calibration like issues. So technically within the company or within the organization, we help the domestic products design teams. So we directly interact with the design issues. We qualify materials and processes, and we have an extensive lab of mechanical testing, polymer characterization, non-destructive testing and failure analysis, electromagnetic testing, and the metrology issues. I'm going to get into details in the following slides. So we are kind of sub part of this huge facility. I have a video showing this composite manufacturing facility. Probably. This building is like currently active, and we produce composite parts for our domestic products. So in our product portfolio, we manufacture indigenous aircrafts, and the most important one probably is the TFX, which is a fifth generation fighter, and we have composites on this platform, and Hürjet. On helicopters, we have Atak, Gökbey. Sorry for the Turkish names, but probably we don't have international names for them as well. We have two main UAV products, Anka and Aksungur, and we are currently producing satellites like GSATCOM, Turksat-6A, and some like renovation projects as well. And we have also the commercial side that we work with this global companies, or like global OEMs of the aerospace industry. And having these products, we have to provide as a department right material and process sources to provide the airworthiness. So our main focus and the activity areas are structural materials. For example, in here we have polymer composites. So for like the confidentiality issues, I cannot like pronounce the names of the materials that we use. So we have advanced composite materials coming from some commercial products, and we currently qualifying new generation composites, including like high temperature materials, some dielectric materials, etc., some other prepregs. And we also have several programs to get indigenous prepregs. We are working with Turkish companies or Turkish partners. So from structural materials, we move to advanced composites, functional materials for some electromagnetic applications, I would call it. High temperature materials for radon and high temperature domains. We need to get some functional materials, which is way beyond like the in terms of like the performance that can provide way beyond the conventional solutions. We have a good facility which is recently like built for thermoplastic composites, and we are getting thermoplastic composites on our domestic programs, and we have autoclave composites as well. So having composite is not only enough, we need to develop assembly and joining technologies. We have surface preparation technologies like the plasma or laser to join composite surfaces together in the most efficient way and advanced methods. Recently, we embarked on a new journey for the canopy and transparency concepts. So for like the previous products that we have, we were getting like this like platforms from commercial suppliers. And recently we start producing or doing some like development like things right now to produce with local suppliers this canopy, the transparent domain, and it's like forming processes as well. So it's a really good project for us right now. We also getting some composites, new generation high temperature, electromagnetically transparent or reflective composites for the radon. Additive manufacturing for composites. We have a huge investment on additive manufacturing processes, including the high temperature plastics and metals. I'm not kind of talking about the metals here right now, but here we produce and qualify parts on aircraft platforms via additive manufacturing, non-destructive testing, and the artificial intelligence. So these are like the conventional solutions that everybody can have right now or other like competitors. With some like joint projects through our offices and international collaborators, we have an ongoing project on, for example, artificial intelligence, and I'm going to be speaking of that thing as well. So it's our department. I'm going to briefly touch on what we do here. We work with metal alloys, composites, assembly technologies, additive manufacturing, surface technologies, processes. For example, we do part and the process qualifications, calibration and metrology. We can calibrate the equipment for dimensional, thermal, and electronic purposes, an extensive test and characterization laboratory for mechanical, physicochemical testing, and non-destructive testing. We have a collective, like 30 plus years of experience on materials. So we have engineers from materials, chemical, mechanical, and electronics departments with PhDs and masters. So we are getting probably like I'm like announcing that probably the first time like in like a tech talk, probably Turk's largest material testing laboratory in a couple months here in Ankara. So we'll be like probably announcing that later on like with more detail. But by March 2023, we'll be having this lab and we'll be getting the NetCap and ISO accreditation. So it'll be like accredited and fully functional materials and processing laboratory. So here's the summary of our accomplishments. We have been on 70 plus like programs. We qualified materials. We did a lot of like material testing, including static and fatigue test, dynamic testing, and did international, internal and external calibration. And here's our partners as the materials engineering department. So we work with these global companies. In the beginning of my presentation, I said we have some offices like global branches. So with the United States offices, we work with several universities, including Wichita State University. With them, we develop high temperature fire retardant composites. So Wichita or Kansas is famous for like its NIR Institute for Aerospace Applications, and we have really good professors and researchers there. So we develop a formula for a composite which is aimed to be used for on our like helicopter program Gökbey, and the TFX for high temperature domains or to prevent like fire toxicity within this like the cabin or fuselage. So this is a really good project. We are it's almost complete. I believe like a couple months left, and then we'll kind of be qualifying this material for this platform. So the formula, everything is set. So it was a success for us with the little budget for such a platform. Other main accomplishments, one of them like probably we have done like in the past year is the digital twin process for mechanical testing. Normally we do mechanical tests by conventional machinery like Instron, MTS, whatever. So it takes a lot of time. So you need to spend a lot of money to produce the parts and get the test results and analyze. With the University of Illinois Urbana-Champaign and the NCSA National Center for Supercomputing Applications, with them, we developed a machine learning or AI algorithm to predict the fatigue properties of materials with some digital tools. So the result is very like impressive. We got like 95% accuracy, more than 95% accuracy, and we took down the number of tests by 70%. So let's test a lot of accuracy, and we have like a way to go. So we are getting into the second phase of this project. So in this second phase, I am really excited to be in this project. We will use synthetic data obtained through AI tools to design an aircraft part, like subpart, like a detailed part, and then we'll do some dynamic analysis testing for that part, and we will qualify our testing procedure. So if that works, we probably won't need any conventional mechanical testing tools, etc. Or it'll be limited in that way. So it's an ongoing project, and we work with top economy and technology university in Ankara in this project. So also for composites, excuse me. So for composites, we did actually recently finished, excuse me, a thermoplastics project with Boeing, BRT. They have an office in Istanbul. We have gathered a thermoplastic processing machinery and process, which is qualified by them and by our team to produce airworthy thermoplastic parts. So I have a short video that I would like to show. Oops.
Isı mı veriyorlar ona? Isıttılar, form verdiler. Güzel de parça çıktı. Oh, okay.
So this project was on national and international media as well. So it gathered a lot of attention for our thermoplastic manufacturing facility. So this is not an R&D project. It's a joint co-development project of a manufacturing process. And as we finish the project, we are planning hopefully getting these thermoplastic parts in mass production level. So So I believe this is my final slide. As I briefly mentioned, we'll be getting this Problem Nation's top material and process and calibration laboratory by March 2023. We will be probably, if the things go well, we'll get accreditations from NetCap and ISO 17025, in which we will have mechanical testing lab, polymer characterization lab, chemical analysis lab, electromagnetics and optics lab specifically for canopy projects. We will have an environmental testing lab for different like UV, like temperature parameters, a microstructure and NDT non-destructive testing lab, and a calibration lab. So we are excited to be in this like facility and probably supporting all the material testing efforts in nation or worldwide. Thank you for your time and being here. That's all I have for today, and I'm happy to take any questions you might have.